Hello again, I'm back. I was hoping to try and do a video every day, but then my leg got injured, and then I got sidetracked, and, well, I'm back. That's what matters, okay? Today we're going to be looking at chemistry, as you could probably tell by the title of the video being chemistry, or something related to chemistry. And we're looking at chemical analysis. Because what's more important than being able to tell what chemicals you're working with? When working with chemical analysis, it's often helpful to understand what purity is. Now, in chemistry, purity refers to a substance that has nothing added to it and it's in a neutral state. You can probably tell because purity, and it means it's a pure substance being itself, just itself, it's not contaminated, there's everything in it, etc., etc. It's helpful to understand what purity means in chemistry because when you're working with a chemical that's not pure, it can, you know, make the results a bit iffy. There are so many ways you can identify chemicals, right? But if you don't know how pure it is, it can, as I said, skew the results. So, to understand how pure something is, you can work with its melting point and boiling point. If you know the exact melting point of a substance, and then you can test it, if it's got a different boiling point or melting point, you know, it's not pure, it's not itself. It's just because, let's say you have a substance with a melting point of 50 degrees Celsius, okay? If it's been contaminated with something else, the boiling point may be higher or lower than what you expect it to be, and you can tell that by a test. Now, you have formulations. These are actually just substances that you that are meant for a precise purpose with exact values, etc., etc. Things like, you know, paint and stuff like that. Paper chromatography. This is one of the simpler ways to... It's not really simpler, it's just that this is one of the things that you'll probably first learn. Actually, did I cover paper chromatography in my other video? I'm not too sure if I did, but I'll do it again just in case you've either forgotten or I haven't done it and I'm just making things up on the spot. But with paper chromatography, it's you use paper and it's chromatography. So you put the chemical in the paper, you put it in water, and the chemicals will move up the paper and you'll be able to see what's in it, etc., etc. Now, there are different steps and stuff you need to know, and there's actually a formula related to this to work out the RF value, so there is that as well. You have two phases in chromatography. You have the mobile phase and the stationary phase. The mobile phase is, of course, when things are mobile and they can move, and the stationary phase is, well, when they're stationary. This refers to the molecules in the paper, etc., etc., etc. Now, I'm pretty sure I did actually cover this in the other video, paper chromatography, but I don't know if I covered the RF value and the calculation to work it out. Now, what the RF value refers to is the ratio between the distance of the solute compared to the solvent. Now, there's a calculation of the RF value, and the RF value is the distance travelled by a substance over distance travelled by solvent. Now, moving on to more chemical analysis. There are 4 gases you need to be able to identify with the chemistry stuff. Now, what this is you have to be able to test for carbon dioxide, chlorine, oxygen, and hydrogen. Now, these all have separate tests of their own. Now, the one for chlorine is bleaching litmus paper, specifically blue litmus paper, to be more specific, damp blue litmus paper. So what you do is you have chlorine gas, it's yellow and very bad if you breathe it in, and you get some damp blue litmus paper and it bleaches the litmus paper. So if you put it into the gas, it will initially go red, but they'll go white afterwards, since it's chlorine is the main ingredient in bleach after all. Now you have a test for carbon dioxide, which is lime water. I nearly said lemon water. With calcium hydroxide or lime water, if you put carbon dioxide into it with like a tube or something, it will turn cloudy. And I've heard the term milky be used before, but it just sounds weird, so I would use the term cloudy. A hydrogen gas test is called the squeaky pop test, which, as it kind of says in the name, if you get a test tube of hydrogen and light it, it will go squeaky pop. And that's how you test for hydrogen. Now the oxygen test, there is an actual word that you have to use for this, because let's say you've got a tube of oxygen and a lit splint, okay? If you blow it out, it's kind of glowing, you know, with all the different embers and all that, okay? And the phrase that they want people to use in the test is a glowing splint. I don't know why, specific terminology. If you use any other term, I mean, you might get a mark if you described it. I don't mark papers, okay? Anyway, if you have the oxygen and test tube and the glowing splint in one hand, if you put it in the oxygen, the glowing splint should relight. So that is the oxygen test. So yeah, those are the 4 tests. It's for hydrogen, oxygen, chlorine, and carbon dioxide. There is a way to test for sulfates in a solution, and this is, so this is just a way of identifying what's in the solution. So to test for sulfates, if you've got a tube of your mystery liquid, you want to grab some dilute hydrochloric acid, put that in first, and I think it's barium chloride, and you put that in. Yeah, and then you just shake it about, and what should happen is a white precipitate should form. Now, what a precipitate is it's basically something solid that will form in chemical once you do it. It's terminology, man. Terminology is important in everything. Now, moving on to another test. Another test that we're going to be talking about is a test for halides. Moving steadily on into the halide test. Now, what this is if you had your halide solution in a test tube, you add a couple drops of nitric acid, then you just add a bit of silver nitrate into it, and whatever halide it will be a certain colour. Now, there are 3 different colours relating to 3 different halides. The different colours that you can get is if there's chloride present, you get white precipitate. If there is iodide present, you get yellow precipitate. And if there is the other one, bromide, you get a cream precipitate. And then you can tell through the different things what halide is present in your solution. Now, one of my favourite tests, despite it not being one of the best tests you can do, because there are multiple things that can go wrong, but it is still one of my favourite tests, the flame test. The flame test. Now what the flame test does is it tests for metal ions, okay? The way the flame test actually works is when you spray or whatever with the liquid over a flame, it will burn a colour. This just happens because when it takes in the infrared radiation and all that, the electrons will kind of get pushed out due to energy and to the outer shells and pushed back in, and then it emits a visible colour. But you can actually tell what metal ions are present due to its colour. Lithium ions burn with a crimson flame. Potassium burns with a lithium flame, I believe. No. Potassium burns with a lilac flame. Sodium burns with a yellow flame. Copper burns with a green flame. Calcium burns with an orangey red flame. Now these are all the terminology you will need just because, well, terminology. And actually, one of my favourite chemicals now, and yes, I have a favourite everything. I have a favourite star, a favourite chemical, a favourite physics equation, a favourite Newton's law. Okay, I know, I'm weird, but strontium is now one of my favourite chemicals. Not only because of the name, strontium, it sounds awesome, it also burns with the most amazing colour. It's like this really deep red. Anyway, the next test we're going to be talking about is about forming insoluble hydroxides. Now, what this is it can help you identify what metal is, metal, or cation is in your chemical, because it will form a precipitate of a specific colour. Now, you have calcium, it will just form a white precipitate. There are actually 3, I believe, which form a white precipitate, but one of them has kind of a special condition which you'll be able to identify from the rest. But anyway, so yeah, calcium will form white precipitate, aluminium will form a white precipitate, and magnesium will form a white precipitate. But one of them, aluminium, has a special condition where this precipitate isn't actually insoluble, because after a while it will dissolve back into the solution you have. So it will make the precipitate, and you can identify aluminium through the dissolving precipitate. But it will still appear, and you'll still be able to identify it through that. Copper will have, or copper 2 specifically, will form a blue precipitate when added into the solution. Iron 2 will be green, and iron 3 will be brown. I should also mention that you add sodium hydroxide into the solution to get the precipitates to make the insoluble hydroxide. Now you have flame emission spectroscopy. Spectroscopy, yeah, that is how you pronounce it, right? Spectroscopy. Spectroscopy. Spectroscopy? Spectroscopy. Anyway, however you pronounce it, flame emission spectroscopy, stuff. Now, what this is, it's basically, I like to think of it as a more advanced version of the flame test, just with a lot of technology involved, and it's much more accurate, it's probably faster, and much more dependable. Now, what this is it uses the machine to identify what chemicals are in the flame test, basically. So it does the test in a chamber, and it can identify which colour is coming up in the test, and it'll be, okay, this colour represents this colour represents this, and it gives off this chart with a bunch of lines on it, and you can check that with another bunch of lines which represent this, and you can say, okay, these lines appear here, and these lines appear here. It's better if I just get up a graph or a picture, so I will do that right now. Now there might actually be a question about flame emission spectroscopy where it will tell you to identify what ions are present, and it will give you that bar with a bunch of lines in it, and it might give you 2 or 3 options saying this is calcium, this is strontium, this is this, and you have to say, okay, these lines appear here and in the sample we've been given, so calcium must appear here, or strontium must appear here, but the other one doesn't because these lines don't match, therefore this substance is made up of calcium and strontium, etc, etc. So those are the kind of questions on flame emission spectroscopy. And speaking about wait, hang on, what? No, we're just done. I hope you guys have enjoyed this video. I didn't realise I'd be finished so quickly because I thought I had a couple more pages to do. But no, we're just done. That's chemical analysis, C8 chemical analysis for you. I hope you guys have learned something, and goodbye, I guess.